2. And that would be it. So this one has only one solution. Beautiful. Bye. It's gonna give me a... Hi everyone. Let's do question 5. Rearrange these equations into general form. What I'm gonna do here, or how I'm gonna do it, is pretty much using cross multiplication. So I'm gonna cross multiply. So that's gonna give me x times x plus 2 is equal to 4 times x plus 1. And now expand this. So by multiplying x with every single term inside the brackets, it's gonna give us x to the power of 2 plus 2x and equal to. Same here, multiply every single term inside the brackets by 4. So it's 4x and plus 4. Next step is to put everything on one side, because we do want to have 0 on this side. Let's get rid of or cancel out 4x. As 4x is positive, the opposite would be negative 4x, and that would give us 0. That's gone. But whatever we do on one side, we have to do to the other side as well. So let's rearrange this. It's going to give us x to the power of 2 plus 2x, take away 4x is negative 2x, equal to, this is 0 as we said, and we have 4 on this side. Same. Now we have positive 4, we want 0, so if we do take negative 4 away, it will give us 0, and we have to do the same on the left hand side. So rearrange, and it's going to now give us x to the power of 2, take away 2x, take away 4, and equal to 0. So this equation has been rearranged, written in general form. Part B. So this one does look a little bit different. So we do have x in denominator. I always try to get rid of whatever is in denominator, and this time is x, and I'm gonna do that by multiplying everything by x. I'll just write this equation again to show you one more step how I'm gonna multiply everything by x. Let's use red. So multiply by x, multiply by x, and multiply by x. X times x is, so multiply is x to the power of 2. X and x gonna cross out, plus and minus is gonna give us negative 2 and equal negative 4x. Same as we have done before, we do want 0 on this side. Negative 4x, opposite of negative 4x is positive, so that's gonna cancel out each other. It's gonna give us 0 as well. So, and we're gonna do the same on the left hand side. Rearrange x to the power of 2, negative 2 plus 4x is equal to 0. And just to make sure it is in the form that we have up here, so I'm going to rearrange x to the power of 2, then plus 4x, take away 2, and is equal to 0. So this is in general form. So no need to solve this one. So if you do want to, there are different methods, factorization, graphics calculator, and so on. Okay, let's move on to question 6 now. So it's a little bit wobbly, isn't it? So question 6, use a discriminant to determine the relationship between the graph and the x-axis for those two equations. The first one here is y equal x to the power of 2 plus x plus 1. So discriminant, we have to use discriminant. Discriminant is that part of quadratic formula, the one under the square root, and it goes like this for AC. Okay, so let's first establish what are the values of A, B, and C. So A is equal to 1, B is equal to 1, and C is equal to 1. And next, substitute B, 1 to the power of 2, take away 4 times 1 times 1, and it's equal 1, take away 4, and take away 4. instead 4. Let's erase them. So take away 4 and it's equal negative 3, which is less than 0. So what is the relationship between the graph and the x-axis now? We do know when discriminant is less than 0 that we don't have real solutions. No real solutions. No real solution. What does it mean in the term of the graph? So we don't have any axis, which means graph does not cut the x-axis. So next one, let's have a look at part B. Okay, so discriminant, which is here, so I'm not going to rewrite it, that's discriminant. But what we're going to do, we're going to find out what A is. A is equal to 1, B is equal to 2, and C is equal to negative 5. So you don't have to do this all the time, A equal this, B equal that. Yeah, I'm just doing it for the purpose of, the teaching. So discriminant is equal to, what is B? 2 to the power of 2, take away 4 times 1, and then times negative 5. So this is going to give us positive number, 4 times 1 times negative 5, 20. It's 24, which is bigger than 0. So we do know when discriminant is bigger than 0, because we have solved quadratic equations before using quadratic formula, and so we have seen, how it does look like when we have two solutions. So this is going to give us now two solutions, two real solutions. What does it mean in relationship between the graph and the x-axis? It means pretty much that graph is going to cut x-axis twice. So two real solutions, one here and one there. Beautiful. See you soon. Bye.